Okay. Hi, Foundation students. This is Dr. Frakes. I'm going to go ahead and explain how to go ahead and use your H-bridge, which is required for your robot to get your motors to work properly. And before we jump into this, let's go ahead and look at what we need. This is our H-bridge. We will need an Arduino and a breadboard. We'll need our motors, which are these yellow 6-volt DC motors. You'll need a bunch of different wires, male to male and male to female. And additionally, you'll need a battery pack. Now, I currently do not have my battery pack, but if you go to Canvas, you can see that this thing here is the battery pack that you would need. It holds 4 AA batteries, which leads to a total of 6 volts. That will ultimately be used to power different components of this circuit here. Now, looking at this, we see there's a lot of wires going around, a lot of complication. So my goal for this video is to try to clear up some confusion that is associated with these parts. So first off, let's go ahead and look at our H-bridge. What this thing is doing is it will take signals from the Arduino, meaning that they're high digital signals or low digital signals that are outputted as being 5 volts or 0 volts. And those signals, depending on how they are programmed, will tell a motor to spin clockwise or counterclockwise. And doing so, that allows us to determine if our robot's going to move forward, backwards, if it's going to turn in any sort of way, depending on the direction that these are spinning. And that is what this chip does. So let's go ahead and explain the different components of this. First off, if we look at these 3 screws here, underneath you'll see that we have these holes. This is where your wires will go, and we'll tighten them down. These 3 are associated with power. So if you look at it, it might be difficult to see. Let me see if I can autofocus to get it better. You can see, and you can do this yourself, plus 12, ground, and plus 5 volts. And we'll wire all 3 of these up. So let's explain what they are. The first one that's on the left, this will power our motors. And this will come from the battery pack. In the middle, we have our ground, which we always need to complete a circuit. And then this last one is power that is needed for the circuit board itself. Now, this is optional depending on how much power you provide here, but it is common if you're limited in power to provide your own power source here, power for the H-bridge. And this will come from the Arduino. So those 3 parts are crucial in order to get this thing to work properly. So that's the power. The next thing we have to look at are these 4 pins here. Again, if we look at it closely, we can see that says in1, in2, in3, and in4. Those are input signals that ultimately tell our motor what to do. They are associated with these output signals. So you see out 1, out 2, out 3, and out 4. So what we're going to do, and I'll put that to the side, this guy, we already know that's for the power. What we're going to do is we'll go ahead and all 4 of these will go to the digital Arduino pins, because that's going to be the way we program this, the way that we determine what direction the motors are spinning. So we have power at these blue screws. We see that these are pins sticking out, so we'll use female connectors there. And the final thing we care about are these 2 sets of blue things here. Similar to the others, we'll stick our wires in between these metals and screw down in order to tighten it. And these will ultimately go to our motors. So I wrote that as motor 2 because that is inputs 3 and 4. It's not a big deal how you'd call it. But those ultimately go to our motors, and we'll talk more about what that looks like shortly. So for this, we would like to power this first based on what we were just talking about. So let me get the breadboard over and our Arduino. And the first thing that we're going to do is let's get the power from our battery source in the breadboard. And if you look at your picture, you'll see that we end up powering, I'm going to actually flip this around. Do I want to flip this around? Now we'll leave it like this. It's fine. We'll end up powering the positive terminal of this breadboard, where everything in this column is at the same potential. So I'll take the red wire, at least from my 9-volt battery. I have this adapter that allows me to take the signal out of this and use it in the breadboard. And that will mean that this entire thing is going to be at 9 volts. This other black wire will be ground ultimately. I'm not going to plug that into here yet because of the fact we'll be wiring. We don't want to be in any sort of danger at all. So we want to be safe and make sure that our circuit isn't complete until we're fully done with it. We don't want to break any parts possibly. So with that in mind, let's begin setting up what we were talking about before. Actually, I'm going to make it a different so we can show this. So as I mentioned before, if we're worrying about the power, the spot on our H-bridge that powers the motors, that comes from the battery. Oop, this came out, which comes from here. So what that means is I will take a positive pole, put my wire in, and then I'm going to put that into this area here. So what you'll do is use the screwdriver in your kit to unscrew it. And then you'll put your red wire in, or any color wire. I typically do red for the positive, and then tighten down. It's very important to note that these may strip easily. So be very careful when you're tightening. And you can do a little tug to make sure that it's snug. And in this situation, it is. So now we have provided power to the motors, essentially. Another thing that we need to provide power for is the Arduino itself. So if you look at your Arduino, and the reason that we have to do this first off is because we're going to be not using a laptop when you have your final robot. At the end of the day, this entire thing needs to be inside your robot, so your robot is freestanding. It's not connected to any external things like a laptop or a computer. So we have to turn this on with our battery. So in order to turn on the Arduino, you'll see that there is a spot here called VIN. That is our input voltage. We'll take a positive terminal from this column and then feed that over to VIN so that we can power the microcontroller, the Arduino. I'll go ahead and I'll put that into one of these columns. It doesn't matter which. And I'll go ahead and put that into VIN. And let me just show what we've done so far. We come back to this drawing. I have plugged in the red wire from my battery into this positive column. I have one wire that goes to that leftmost spot for the power for the H-bridge motors. And then I have one more wire that's going from this positive column to VIN on the Arduino, which is what we just did. So now we have power to the Arduino and we have power to the motors. The next thing we want to do is make sure that we're providing power to this column, the rightmost one. As I said before, you need power for the H-bridge, and that comes from the Arduino. So I'll take another wire. And if you look at your Arduino, you'll see that there is a power output here. See if I can zoom in on that a little bit. There you go. We can see that it says 5 volts and 3.3 volts. Those are outputs. So what we want to do is plug into 5 volts. And that will ultimately be fed through to here, to that rightmost column. And because of the fact that this wire is a little short, I'll just arbitrarily put it in some row to extend the wire, essentially. Because remember, this row here is connected So if I have the output of 5 volts going to this row, that means this whole row is connected. This is basically the equivalent thing of one long giant wire. I just don't have that, so I'm using this to help us. So now I'll go ahead and plug that into the rightmost pin of the power for our H bridge. I know there's a lot of wires going on here, but let's just double check what we just did. I have taken V in from the Arduino, which is here, 5 volts, or not V in, sorry. I've taken the 5 volt output of the Arduino and I have fed it into this third hole. The next thing I would like to do is ground this, and I know that I'm going to have my ground be tied to the negative terminal. That's common for us to do. So maybe I'll use yellow for that. I'll go ahead and put yellow into this. We'll ultimately take our black wire from our battery and put it into this. But for now, we'll just put that yellow in there, and I'll make sure that that goes into the ground of the H bridge. I'll tighten it down. And now I am grounded. Cool. So we are done with the power section of it. The next thing we want to do is understand the digital pins that go ahead and interface with these physical pins on the H bridge to produce the turning of the motors that we want. So I have the code from the Origami Bot. Whoa, what's happening? Oops, that was weird. Okay, so if you look at this, we see that we have in1, in2, in3, and in4. They correspond with the in1, in2, in3, and in4 that are on the H bridge itself. And based on this code, in1 is tied to Arduino pin 4, in2 is tied to Arduino pin 5, and so on. So we have to go ahead and match this to our code. Of course, if you mess this up, you can change one of these pins so it's not 4. Maybe you accidentally plugged it into 3, and instead of untangling the wires, you just change the code here. That's fine. But in general, what we're going to do, we'll try to match this for convenience so we don't need to change the code at all. In1 will be assigned to digital pin 4. So if you look on your Arduino, you'll see that you have all these digital pins. Here you see it says digital. We're going to go from pin 4 to in1, which is on our H bridge. Now for this, we'll need male to female wires, because over here we have to attach to the prong sticking out. So that's the female end, and then we'll take this and we'll go to pin 4. So you can see that I plugged it into pin 4. That's pin 4. Going into input number 1 in the H bridge. Let's do the same thing. I'll get a different color. Then we'll go from in 2. And based on our Arduino, pin 2 corresponds with pin 5 on the digital side of the board. So I'll go ahead and plug that into pin 5. Now I have 4 and 5 next to each other. That's fine. We'll do this again with in 3 and in 4. If we look at in 3, we see that's 9 and in 4 is 10. So we'll go from digital pin 3, which is this guy on this bottom, digital pin 3. And that will go to pin 9. And then we'll do one more. That'll go from pin 4, in 4 on the H bridge to pin 10 on the Arduino. I know this looks very messy right now. I can relate. I see that. It's messy. But I'm hoping you're following along slowly, and we can compare to this. What we just did was plug these 4 wires in from in 1 to 4, in 2 to 5, in 3 to 9, and in 4 to 10. So we've handled this. We've handled the power. The last thing we need to do is hook up our outputs of our H bridge to the motors. So let's go ahead and do that. So if you look at your motors, you'll see this yellow motor. I'm going to move this aside for a second. And the question is, where do we attach to? Well, at the top, you'll see that there's these 2 golden arches here, or these 2 golden hooks that you can attach to. One of these will be the positive and the other will be the negative. And we can't really tell which just by looking at it. But what to note is that if you accidentally switch these, you think this is positive versus that is positive, you'll see that the motor will spin in the direction that is opposite what you expect. And if that happens, you can change the flipping of those wires, or you can change your code, and I'll go through that shortly. But what we're going to do is attach the wires directly to those gold leads that are at the top of the motor. So I'll pick some wires here, and I will put them into one of these motors, one of these outputs. And I'll do the other wire and go into the other output right there. And this side is associated with one motor. So what I will do is I'll attach one of these to this gold lead. And what I typically like to do is hook it. Yeah, I hooked it. Now it's harder to come out. You could tape it if you'd want with electrical tape. That's fine also. And then I'll do the same thing with the other one, and I'll hook it. And now we have our circuit. Let me zoom out a bit so we can see everything. So we have all of our wires hooked up. The last thing we need to do is hook up the ground to complete the circuit. Oh, actually, the one thing I forgot is that we haven't grounded the Arduino as well. So what we need to make sure we do is that this will be the ground of our electrical circuit. That will go into here, into the negative terminal. We also have to ground the Arduino. So the Arduino has open pins for ground. I'll just grab one arbitrarily. You can see there's a ground right there that I just plugged into. I'll also plug that. Oops, this is male to female. Let me get male to male. I'll go ahead and plug that ground into the negative column of my breadboard to make sure that everything's grounded properly. We need the H-bridge grounded and we need the Arduino grounded, which is what we got set up now. So what we'll do last is we'll plug this in. And I've already coded this. I've already uploaded the code. We can see that our motor is spinning. And if you look, it's spinning counterclockwise and then clockwise, and then it stops. Clockwise or counterclockwise, clockwise, stops. So this will be true for the other motor, which you also need to hook up. I'm not going to hook it up now. I'll let you do that on your own. But let's figure out why that's happening, this idea of it moving one direction and then the other and then stopping. So if we come to the Arduino code, we see that we've set all of these pins as outputs, meaning the digital pins. And the first thing we do is we set in 1 to high and into the low. And remember that 1 and 2 go together and 3 to 4 go together. So let's just look at one set of these. In 1 is high, in 2 is low. What that means is one of these guys will be set to a higher value. The other one will be set to low, so maybe 5 volts and 0 volts or something along those lines. And if we have something that's high and low, we'll have current travel from the high. It'll go this way through the motor and then come to ground, or to 0 volts, to low. Because the direction of current is flowing a certain way, this will cause this thing to rotate in one direction. If we come back to here, we look at again a second later. Oh, that's the other one. I'm dealing with in3 and in4. So high and low, just like I said. This one will then switch it. Instead of in3 being high, in3 will change to low. We see that, right? Digital write in3 high, then we'll do in3 low. And then in4 was originally low, and now it's high. So what that means is instead of the current flowing out of here to the motor and then back, it's going the opposite way. So current's actually flowing out of this to the motor and then coming to low, which is here. And that direction of the current changes the direction of the motor if it's spinning clockwise or counterclockwise. The last thing is that if we come to here, we'll see that at the end of this, originally, if we look at this, we see that in3 is low and in4 is high. They then make in4 low. So at that point, in3 and in4 are both low. And if they're both at the same level, there's no current that's going to flow. You're only going to have a current if you have a difference in voltage. If they're both low, there's no current flowing, which is why this stops and it doesn't move. So again, just to kind of reiterate this, I'll plug this back in. We'll see that this goes one way, the other way, and then it stops one way, and then the other way, and then it stops because of that logic. Now, if you include both motors, you'll see that they're both doing different things. The robot moves straight, then the robot turns, and then the robot moves backwards. I only looked at in 3 and in 4, but if you follow this logic with in 1 and in 2, it might help you a lot understanding this, which is very useful for the future when you build your robot. So again, the circle we built is right here. You can see that I attached the 2 wires from the H-bridge to their respective motors. We made sure that we grounded everything that we needed to ground. That includes the H-bridge itself that's being grounded to the negative terminal and the Arduino that's being grounded to the negative terminal. And in regards to power, we provide the power from a battery. That power will go to the H-bridge itself, the Arduino itself in VN, and that optional thing that we have to use for the circuit, well, that will come out of the Arduino itself. So that's going to come from 5 volts to there. I hope that this helped. Please go ahead and rewatch it if you need to and follow along slowly. But I'm hoping that this will help you for your Origami Bot that's due shortly. Okay. Thank you. I will talk to you soon.